Hey guys, am I audible? Please confirm in the chat if I'm not audible. Okay, we are into contact session 6, and we are going to look at the models of IAS, where we are going to concentrate a little more on the compute database and storage. This will be the region and availability zones. And we are going to look after a case study called OpenStack. Let me present my screen. You can share my screen. So this is for today's agenda. Okay. Directly take you. So we all know what is AWS, and when it comes to EAS, that is infrastructure as a service, we pretty much concentrate on the AWS. Okay, again, they provide a lot of remote services, and they also called as web services. So web-based virtualization is given to you through a website, that is Amazon.com. So you have they are based out of 11 geographical regions across the world. Now it is still got increased, and most central and well-known services are like Amazon's EC2 instance and S3 bucket. These products are marketed to large companies, and they provide large capacity as well. So computing facilities in a faster and cheaper than other companies, how they give physical farms. Okay, here cloud provides you such physical farms so that you can use enough resources based on your business requirement. So when it comes to compute, we have EC2 instances, which gives elastic cloud compute. That's what EC2. And they provide virtual private servers, which is running on Zen infrastructure, that is Citrix virtualization. And EMR is Elastic Map Reduce, and which is used to by the researchers and data analysts and even developers to use vast amount of data to be stored on their Amazon's infrastructure. Okay, they host Hadoop framework, and these instances can scale up to how many number of nodes if you want to expand. Okay, like you want to have 1,000 nodes in the sense 1,000 VMs, and you can also store data into the Amazon S3 bucket. So when it comes to networking, we have three parts over here. Like one is your Route 53, other one is your virtual private cloud, okay, which will be default to your EC2 instance. How you need a network, right? So let's say you want your VM to be more secure, so you need to create a network, and into that you will have a subnet, and in that subnet only you will host your what is that VM. Okay, so a generalized network architecture will be. Similarly, cloud will also create you a virtual private cloud, and top of that, you'll have all these information. So like it's again, these VPCs gets you a logical isolated set of EC2 instances. Let's say You can stop internet to few of your subnets, and you can allow internet to few of your subnets. So that security is also improvised a lot. This Route 3 provides uh, you can set up a domain name web service. Let's say you're hosting your website to the outside world. And how you'll be hosting is regularly, if you want to host a website, you need two things. One is the domain name service, which is given by GoDaddy or some hosting provider who is available in the market. A lot of hosting providers currently available in the market. One is GoDaddy, and many more are there. Similarly, we can also set up a private hosting service using AWS through Route 53. Okay, you can set up a domain name service, and then through this, you can host your websites. You can have those storages in easy to instance or on a S3 bucket. You can do that as well. The third one is a direct connect. So how data centers function? Let's say your data centers is located in Hyderabad, as we discussed, right? Some will be in some other regions geographically. In India, if you take, it is there in Hyderabad, it is there in Mumbai. And if you want to have a direct connection from your office premises, so that how you connect to internet is, how I connect to Amazon is through website, through my ISP provider. Let's say I have a Hathway internet at my home, and through that, what is that? I browse my services and I access to those services. Whereas if you want to reduce the delay, the internet providers have direct connection to each and every city. Let's say if I am in Chennai or if I am in Bangalore, I have a location where we have Amazon's data center itself is providing a direct connectivity through our internet provider. So that can be done by this AWS Direct Connect. So even in Azure also we have virtual network. So all the major players who provides infra as a service, okay, they will have all these products. Next is your content delivery. Okay, so if you want your, for example, your hosting. Let's take Google. Sorry, the YouTube itself. So YouTube is hosting their videos, okay, through their application, okay, through web. So whenever you try to access a video through YouTube, what happens? It is getting loaded from the actual server where it is stored. Okay, let's say it is stored in some server. When you access that link, what happens? It is fetching the video from that particular server and it is showing it to you in your browser. Okay, so through your YouTube application, web application. So not only YouTube, any other website. Okay, you take Flipkart, any e-commerce website. So what happens is going forward, like when how so when these attackers they try to access these servers, they will be directly accessible to those servers. So to improvise speed and accessibility, they have introduced this content delivery networks, okay, called a CDN. So what they do is they distribute these data into multiple servers on edge location. Let's say my data is stored in US, but users are located in Chennai. We will be always go to the ISP in Chennai or Bangalore or Mumbai, and then from there it will be routed to the US server. So instead of that, that data will be posted or hosted in all the delivery networks. Okay. So such delivery network is called as we can set in Azure, which is CloudFront. Whereas in AWS it is CloudFront, and in Azure it is Azure Friendo. So this will have a auto load balancer facility. Okay. So even when load peaks up during a period of time, let's say you release a trailer, okay, for a new movie or a new music launch, what happens? A lot of users, it will be more. Okay, if those number of hits are directly reaching the respective server where it is actually sourced, okay, and that server might go down. So if you have a CDN, this will also do load balancing because it will store in multiple locations based on the location request. From there, it will be served. Okay, next is storage and content delivery. As you see, where you store your data on the cloud. So you store on S3 buckets. Okay, so web service based storage, any objects you can store here. Even in Azure, you have separate storage. Let's say for file, you have file storage, for blob storage, for table also you have storage. Okay. So here it is, all those objects are grouped and you can put those objects into an S3 bucket. Next is Glacier. So let's say uh, you have certain data. You can take some publishing media. Okay, they are printing books every 5 year or 10 year. Okay, now they have printed a book. After this book will be released after 10 years. Okay, or some 3, 4 years. So until then, they won't touch the actual content of the book. They have to store somewhere else in the public cloud. Let's say they can store it in Glacier, and because it provides you even more lesser cost. Okay, when compared to this S3, because how frequently you're going to access the data. Based on that, you can archive the data and put it in a Glacier. This you for to access this such data, AWS storage gives you a gateway. Okay, it gives you a block storage virtual appliance so that you can retrieve those backups after some period of time. So only retrieval cost will be there and the storage cost will not be there. Let's say from your system, from your EC2 instance, you're storing into your Glacier, that won't cost. So the vice versa will cost you. That also very less. Next is your elastic block store. So all your block level storage volumes, okay, for EC2, they are managed over. Let's say uh, any cloud, if you take, your storage will be separate and compute will be separate. Okay. If you take EC2 instance, it will be only compute and memory. That is your CPU and RAM. Okay. The hard disk drives will be separate. So those hard disk drives are called as volumes over here. And then the last is which is managed through this plastic block store. So here they used to call us volumes. Okay. Wherein in Azure they used to call it as normal drives. Okay. Next is your AWS import and export, which is used to accelerate if you are going to move a large amount of data to a portable device. Okay. Let's say your data is present somewhere else. In terms of device-based content also, they'll give you like they will store it on a hard drive and they will ship to your office. So if you have a private cloud, you want to move all your data from your public cloud to on-premise, for that also facilities are there. So next is database. So a lot of databases options provided by Amazon. So one few things we'll see here. One is your Amazon DynamoDB, okay, which is a NoSQL kind of a database. Okay, and all these database services are backed by solid state drives. Next, you have an Elastic Cache, okay, for web application. So this Elastic Cache is provided by Redis or products like Memcache. So your web application is having you need your web application to be accessible at a higher speed. So you can include this Redis cache so that it will help you to increase the accessibility speed of your web application on the internet. Next, you have relational database services like all these databases are scalable. You can grow to any extent. So Amazon itself provides you MySQL, Oracle, MS SQL Server and PostgreSQL SQL. And you have another database called Redshift, okay, which stores data in terms of data warehousing capacity, okay, like column-based storage or multi-node compute. The last one is the simple DB, okay, which is like structured data, where it operates on the EC2 instance and S3 to provide the core functionality of any database, how we see. Instead of using a relational database, you can use the simple DB. Next, you have data pipelines where it can be used for data transfer between AWS compute and other storage services. Let's say S3 bucket or Glacier. Okay, you want to have an access on a regular basis. You can also include this data pipeline so that you can do the data transfer seamlessly. The last one is Kinesis, okay, which is used for real-time data streaming, like how your YouTube is working, right? You can also, if your application wants a fields feature, you can use this Kinesis, which helps us to do high-speed data transfer. Next comes the deployment. Okay, so you have cloud formation, okay, and you have Elastic Beanstalk, which will help us to uh, uh, deploy applications, okay, and manage those applications on the cloud. And you have OpWorks, operational works provided by configuration of EC2 services using products like Chef. And coming to management. So when it comes to management, you have Amazon identity and access management. Okay. So this IAM provides you access to all these products, like how you have AD, right? AD, you'll create an AD, and through AD, you will authenticate your users. Similarly, to access S3 bucket or an EC2 instance, you can set up only for these products. This much of users are able to, they need to access, and other users will not be able to access other products. We can restrict in that way as well. Next is CloudWatch. CloudWatch is something kind of a metrics. Okay. So, for example, you have n number of VMs running, and you want to know the performance on those, let's say, CPU memory and availability. You can set up your CloudWatch, and it is a default metrics present in the cloud. AWS. You using that, you can measure the metrics like how the performance is, how the utilization over a period of time. And how you access all these services. Who's that? Someone is unmuted. Anuj, can you please mute? Can someone tell her, ask her to mute, please?
छोड़ छोड़ मुझे बिस्तर में कर हाँ तू रहने रहने इधर छोड़ बिस्तर में नहीं छोड़ छोड़ दे छोड़ चापली कहीं की लेके आने के लिए इतना ना इधर
Guys, I request you please be on mute. So unknowingly, you people are going on mute. Please take care. So through Amazon Management Console, it's a web-based, okay, where you can web-based interface. You can manage, monitor all these infrastructure suite, okay, like just like you can see the list or whatever we have seen now. Even through mobile, we can also manage these applications. Just take a look at this diagram. Okay, at the top, you can see you have the web interface. That is what we saw, right? The management console. And AWS gives us uses Eclipse as their integrated IDE for development using Elastic Beanstalk. And you can see development and automation. You use Cloud Formation or Elastic Beanstalk kind of an application. So it is managed by libraries like .NET, Java. So identity and billing is managed by your identity access management on the left-hand side. You could see IAM consolidated billing. So monitoring is done by CloudWatch. Auto scaling is enabled. The network and routing you have Elastic Load Balancer, Route 53, and VPC. So for parallel processing, we use EMR. We will have an example post our midterm. Okay, we will look after the parallel processing features like how Hadoop helps us to do what is that? Utilize AWS and Azure. It's just payment gateways like even more services Amazon has provided. Okay, so for content delivery, we have seen CloudFront. For workflows, you have Amazon's Mechanical Turk. Next, you for messaging also you have notification services. SNS is simple notification service, and SQS simple queuing service. Even email services is also provided. So we all know the basic backbone, which is the EC2 storage and database. So now you can see where your applications are hosted on top of this AWS. So if you could see, uh, take the availability zones and regions. Okay, you'll have regions, and internal to the regions, you'll have availability zones. Okay, so regions in the sense it could be APAC, India, and what is that? US region. So in US also you have the central US. So like that in India you have a south side as well as central India. So those are like the available regions. And internal to that region, you'll have multiple data centers. Okay, it's a big data center. And internal to that data center, you'll have multiple availability zones for disaster recovery. Something goes wrong on the availability zone, okay, immediately you can switch over the control from the availability zone A to B or to C like that. So foundation services, application services, and deployment and management services. Based on that, this diagram is shown to you. Okay. And so now you can see an AWS cloud architecture for web hosting. So see, you have two EC2 instances in between. Okay. left and right, and it has been attached to a elastic load balancer. Okay, and the bottom also, if you could see, you have app service, and again, it is getting communicated to RDS. So DB subnet, so multiple subnets are there. Okay, if you see in availability zone 1, okay, you have a database, you are using an RDS database, and you have a app server. Let's say app server means you have installed IAS on a EC2 instance, or you are using Apache. Okay. On top of that, you have web servers. Okay, which will be front-ending the users from various entries, right? So here you could see the same architecture is replicated in two places. One is primary and secondary. So see, you have one at availability zone 1 and the other is availability zone 2. Okay. So Elastic Ad service is for improving the speed of the web server or your web applications. Okay. And any shared storage is required. So from app servers, those features are accessed. So the whole VPC you can see. In the VPC, you have created two subnet and they have done NAT gateway. So public subnets. And if you could see at the top, where you have the CloudFront, which is CDN, and you have web application firewall. That is, you are setting up the entries, you are restricting entries, right? So it is a public infrastructure. Okay, so you have a AWS WAF, that is web application firewall. Like you can set up rules only from this entry points will come via this, not the others. Like you can also, what is that? You can set up from this regions, your request will not be allowed to enter into, what is that? To your application. That is to your web service. So AWS WAF, if you see, it is like once you browse right from your computer at the top, like you have example.com, yeah, and media.example.com. So two websites are the entry point where it is configured through the uh, S3 Route 53, okay, Route 53 DNS service. So once you type that, it will reach AWS Route 53 and get it resolved, and then it will be moving to uh, either via CloudFront. Okay, so from CloudFront, these services will be served to the customer. So you can see what are the various services related to web hosting. Okay, this is a diagrammatical thing, and you are going to see first is your DNS service. Okay, for domain management. Second is for edge caching, you use CloudFront. Okay. So this will help us to increase the latency to the customers. As I told, right, your server is hosted in US and you are sitting in India and you want to get the same speed, okay, by reducing the latency. Whereas the people who stay in US and access those applications, they will have faster accessibility. Okay. Whereas if I access from here, it will be, what is that, little bit slower due to the latency. So to avoid that, these content delivery networks, which is provided by the AWS in India, will take those data and store it here, and from there it will be serving it to me. Okay, so next is your edge security. So you have AWS Web Access Firewalls, okay, WAFs. So this will help filter the malicious traffic, and you can also do cross-site scripting, and you can define rules to avoid SQL injection. Okay. Next is load balancer, which is ELB. So this enables you to spread across multiple availability zones. And you can also provide auto scaling for those groups. Let's say you have few VMs in this architecture, right? You can make them scale, okay, to make the load suppressed and to take those load dispersed across multiple VMs, which is provided by the ELB and auto scaling groups. Next is it provides AWS Shield, which helps us to provide protection from the DDoS attacks. Okay, so automatically this will shield the entire architecture. And firewalls with security groups. By default, these VMs will fall onto a security group. Okay, security group in the sense which port is opened, which port through which port the communication happens. Not all the ports will be opened. For example, one VM will have what is that? Only the internet is allowed to the web server in this diagram, not to all the other servers. Let's say you have uh, EC2 instances, right? Three EC2 instances. One is for web server, one is for app server, and one is for your database. So your entry point, the internet will be allowed only to the web server, not to other servers, because they communicate via the other what is that load balancers. Okay, so those subnets will not be accessed directly, so that if you attack the try to attack this application, what happens is only the first primary CDN will get affected and it will not reach the other end. If you reach the other end also, only those web services will get affected. So for that only, if you see host level firewall, host level in the sense for that particular VM, you can set rules. Okay, instead of having a separate firewall where you can set up rules, even for on top of that VM, you can set up rules and you can place it behind a web application firewall. Okay. Next is caching. So caching services provided by Redis or Memcached. Okay, to remove load on the app and database. So database, as we say, you here in this diagram, we have used Amazon Relational Database Service, okay, which even provides multi-AZ database architecture. Okay, so how in the sense multi-AZ in the sense multi-availability zone. Okay, you can replicate those data in another availability zone so that if this availability zone is getting disturbed, your data can be accessed through the next availability zone. And this is for static storage and backups. You can use S3 bucket, okay, which will help us to store objects. Let's say you need to store some data, okay, of the user. Let's say the Aadhaar card information, images, some few smaller objects to be stored. You can store it there, okay, like static data. So you can see web application hosting diagrammatically. So you see content delivery network. So all your HTTP requests from the left-hand side, you can see it is reaching CloudFront and it is routed to web service. Okay, so if you see log files, you can store it in S3 buckets. And those log files, you can even store it on Spot instances or Hadoop clusters. Okay, for analysis. If you want to analyze a large number of log files, you can use the Hadoop clusters. Okay, and store it. So see, from the analytic standpoint, how he does. He has a database and he uses top instances to what is that? Process those data. So here, what all services is required? You use an Amazon EC2 instance, Spot instance, and for reducing, correlating or combining multiple logs together and see data, you can use EMR. Okay, let's say some multiple data are there. You need to group it, classify it, and then provide a result. You want to count how many, uh, what is the type of users has come, and how many kind of requests it has received. So all these things can be done. So you can see for that you have you store it using Amazon S3, and your CloudFront helps us to reduce the latency, and your RDS is for database. So here you could see, right, theoretically. So AWS provides services and infrastructure in building a reliable, fault-tolerant, and highly available web application. So this web application production in the production environment, it gives amount of log information. Those logs have like traffic patterns, user behavior, and marketing profiles. So when the data grows a lot, like okay, your web application grows and your visitor numbers also grows. Okay, so you need to store those logs and you need to analyze. Will be more challenging. That is what we saw. How to construct a scalable and large scale log analytic platform. That is what we saw over here in this diagram. Okay, so the core component of this architecture is you have EMR, which is a web service, and you can use that and you can analyze the large volume of data. So this is a web front end service. Okay, it runs on EC2 instances, and you have CloudFront, which is the content delivery network, which allows or distributes static files to the customer with low latency. And during the access, whenever a user enters and access to those static files, what happens? Log files are regularly updated in your S3 bucket. Okay. So it receives data from multiple web servers or from various edge locations. So this Amazon MapReduce, it uses Hadoop framework to process the data in parallel. Okay. So easy to offers unused capacity. Okay. At a reduced cost known as spot price. So this will also the price will fluctuate based on the availability and demand. Okay. Using spot instances, what we can do is we can extend the clusters capacity. Let's say you want 1,000 nodes to be processed. Okay, you have a large number of data. Millions of records are there. You want to millions and billions of records are there. You want to get it processed in a minimal time. So you can use spot instances, which will run only for some 10 minutes. Okay. Even how the Sentinel works is even for security, what they will do, they will create a VM kind of a scanner, and those VMs will scan the existing production VMs and see what kind of an action it is doing there. So it will run only for some 30 minutes or 15 minutes, the life cycle of that VM. Similarly, here also we can do these spot instances will run only for some few minutes or some maximum 15 minutes. Okay, to run the job. So these results, whatever results we are getting processed, okay, on the by the Elastic MapReduce, what happens is those data will be pushed back to the relational database using tools like Apache Hive. Okay, these data can be stored into databases related to your RDS. Okay, which still simplifies the setup, and it can also scale and across large number of sizes. So this RDS is it prices based on pay as you go model, similar to your EC2 instance. Even this database can also be backed into an S3 database snapshot, and then you can terminate this. So from the snapshot, you can recreate the database whenever it is required. So this is for web analysis. So web log analysis, each and every only log analysis. So first we saw application hosting. Now we are seeing web log analysis. Okay, so now let's see about how weblog analysis works. Okay, so now AWS offers services and infrastructure. Okay, which is which is for building reliable and fault tolerant uh, and highly available web applications. So these web applications generate substantial amount of log data, okay, which can give you some valuable insight. So now we are going to analyze those logs, okay, and that is what we saw, right? How those logs will help us to when the user gets increased, okay, and those the you want to store it and analyze those logs becomes more challenging. That is what this diagram like based on weblog analysis, how you can differentiate the second set of this thing. Next is content and media serving. So how content is, for example, live movie or YouTube kind of data sharing. You can see live stream source, and from there you can see live movie is being shared to the end user. And next is your batch processing. Okay, how you share a lot of jobs in terms of batches, and you can use queues so that in those queues your data will be transferred and those data will be processed in terms of batches. So there you'll have a job manager, you'll have a job data store where all your jobs are stored, and you'll have worker nodes where the actual processing is happening. So this is done in your Elastic MapReduce as well, where the architecture will look like you'll have a queuing system, you'll have a batch processing system. So batches in the sense parallelly multiple jobs will be running. The same job will be run on multiple nodes. So fault tolerant and high availability. So high availability in the sense you can see uh, how it is done. Let's say you can see end user, he'll be using Elastic IP and he will be accessing the application. So the application will be copied and it will be having a primary and secondary kind of a thing. If something goes wrong to the active one, immediately the replacement one will be taking care of that. As you could see, right? Applications, the replacement applications on failure, what happens? It will replace the instant, which is like by just taking the volume separately and reattaching to another VM, and it will be giving it to you. Okay, so those snapshots, that is what point in time snapshots, backups will be taking care. As if in availability A, if you see A, B, this is in availability zone A and the other one is in availability zone B. Okay, now you are accessing your availability zone A. Okay, here you could see at the, sorry. Okay, now you can see here. So Elastic load balancing is here. You can see web server, application server, and database server. Both are replicated in both the availability zones. Okay. So only replicated data layer, it is at the top. Your database is being replicated in both the availability zones. If something goes wrong to the VM in the availability zone B or A, any one of the availability zone will be providing you the access so that your web application has not gone down. Okay. So this is large scale uh, what is that computing and huge data set. So in terms of that, they will store the data from read write data from the S3 bucket. Okay, see high throughput and parallel upload. So we use the import and export option to do that. So at the backend, this operation will be taking place. Next is advertisement serving. So a lot of applications based architecture you can see here. How a user, okay, visitor is accessing the advertisement. How your data are delivered to you through CloudFront. Okay, all the data will be delivered to you. But at the back end, you can see, right? You have ad servers. Okay, you have what is that? Elastic MapReduce for the analyzing the log files. Okay, who is accessed, how many times he or she has accessed the website. Okay, so ad serving infrastructure and your click through infrastructure. That is what you can see here. Next is disaster recovery for local application. Okay, you can see how your data center manages during the local applications when they are into some disaster. So here you can see you have a storage gateway, you have database server. Okay, you have an on-premise and you have data in AWS cloud. Okay, so you have an application server, you have storage volumes, and you have database server. So all these data are replicated to AWS. You can see here. Okay, it is those data are stored into S3. Okay, so from there the data are fetched and it is processed. Okay, if you see you have your database server over here, you have your application server over here, and the corporate user who access through the VPN gateway and he gains access to those data. Next is media sharing. So for online games, so I will share you all these things. Okay, you can take a look. Financial computing. So now let's have a short break. Break for 5 minutes. Did you guys got your AWS credentials? So a few instructions they have given. Let me share that when you for your lab content. You would have also the instructions. Okay, so I'll share this now so that you can just read it across during this break time.
Sir,
Yes.
like this instruction we have received yesterday, and I have already submitted my lab on Monday. So now what I can do for it, because I can't resubmit the same lab.
You can drop an email, okay, or else I'll check with Vanilla ma'am. You have her email ID so that you can.
Yeah, I
Uh,
have already dropped a mail to Vanilla Map.
okay, then she will take care. I will also ask like the instruction has come only yesterday, and the students
Yeah,
has already been submitted. What actions can be done on that? Okay, I'll
sure,
also have
sir.
a word. Yeah, yeah. I will take this to them.
Okay, sir.
Yeah,
Thank you.
yeah, yeah. Others, please follow the instruction. Okay, let's continue with few use cases. Okay, with respect to AWS, Amazon S3. So you can see the insights like how these services works. Okay, this storage service use web services interfaces like REST, uh, SOAP, like Simple Object Access Protocol, and BitTorrent. So you can store objects up to 5 TB. Okay. Now you can see the data, how data are stored. Like you can store analytic data, log files, application data, videos and pictures, and backup and archival. You can move those data wherever it is originated from your application. Okay, for if those data are generated in on-premise, you can just move to this object storage built-in store where you can store and retrieve data from anywhere else. So see how it stores. Okay, so it has like so what are the functionality it does, like it provides access to the data, and you can also optimize the cost based on the classes. And so it replicates data to any region, and you can access it from on-premise or through VPC. So it protects and secure your data, and you can even gain visibility into your storage. Let's say all your data stored in an S3 bucket is private. Okay, no, if you host it in as a public, then only you'll be able to give access to everyone. So the data are secure. So where all these data are used is like for it is used for artificial intelligence. It is used for advanced analytics. Okay, and for machine learning. So see now use cases like you can build a data lake, mm, run big data analytics, okay, artificial intelligence, machine learning. If you want to have high performance computing applications to unlock data insights, okay. So for that you can use S3. Next is you can have backup and restore critical data, okay, to meet the recovery time objectives and recovery point objectives. Okay. So for compliance requirements, you can use S3 uh, for your application so that you can on during downtime you can achieve this RTO and RPO. And you can also run now cloud native applications. Okay, you can build fast, powerful mobile and web-based applications. So you need to have only small storage, right? So you can use the S3 bucket, which is capable of. So S3, if you see, it is a service. Okay, so it might be running on multiple VMs. We don't know what is the background architecture. So they provide you it as a service which is highly available configuration. Your data will not go down at all at any extent. Okay, they do all what is that? Replication, multi-storage, all these things they do at the backend. Next is archive data. So you want to use it as an archival store where you can use S3 as Glacier storage classes. Okay, like which helps us to lower the cost and eliminate operational complexities and gain new insights. So you want to have, as I told you, right, 20 years data you want to store. You can store it, keep it as an archival system. So they call all the data objects, okay, within the resources, they call it as buckets. Okay, so as you see, you can store as many objects within a bucket. You can read, write, delete those objects. So each object is identified using a unique user assigned key, like name valued pair, right? So name key for a particular value, you can set a key. Okay, even if you see you have Amazon mission images, right? So those images are also used in your EC2. Can also be exported to those S3 buckets. Let's say you can store AMA images also into S3 bucket. So this bucket and objects can be created, listed, and retrieved. How you can retrieve it? Using HTTP interface. Through link, you can you can access the data which is stored in that S3 bucket, okay, through an HTTP interface. So that is what is the SOAP interface. Okay. You can use it in your application as well. You want to access that an image which is stored in S3 bucket frequently, you can use this interface and you can access it. Okay, so additionally, objects can also be downloaded by using HTTP GET interface and BitTorrent protocol. So major users in the world you can see, right? Dropbox uses S3, uh, uh, your Minecraft uses. So there, Dropbox is used to store whatever you want to store, right? It's a storage application. But backend you see it uses S3. So coming to Glacier, so if you see, Glacier is again a storage area where you can store the archival data. Like you don't want to access it frequently. You want to store it, and you will be accessing once for a while. Okay, in years, let's say. So those backups you can store it in S3 Glacier. And how it is designed, as I told you, right? It is infrequently accessed, and the retrieval latency time is 3 to 5 hours. Okay. So what the storage cost it gives is like 0.01 per GB per month. Okay, it's very less. So you can store data in terms of TB as well. So this is even more cheaper than the normal S3 service. So data is stored in Glacier in terms of archives. Okay, as I told you, right, archive can have any data like photo, video, and document. So you can upload, you see, you can upload in terms of zip multiple files. Okay, split across. You can see a single archive can be as large as 40 terabytes. Okay, so unlimited number of archives you can store and store it in the Amazon Glacier. Key features like vault inventory, access control. Okay, so retrieval policies, audit logs, and it has integrated lifecycle management with Amazon S3, like how to set policies. Like for example, over a period of time, it will maintain the what is that relationship. So see, Snap optimizes cost saving uh, while storing almost like 1.5 trillion photos and videos on Amazon S3 Glacier. Okay, instance retrieval. So if you see Pinterest, those are organization how they use S3. So Pinterest uses Amazon S3 Glacier Deep Archive to manage storage for its visual discovery engine. So Pinterest gives you a lot of data. Okay, if you search, it will give you. So next is Nasdaq uses AWS2 for their stock exchange storage. Next is Cube Cinemas. So Cube Cinemas also takes movies from stage to screen, okay, faster on AWS. Next is your block storage. So it is a persistent block level storage called as volumes, okay, where it is attached to any EC2 instance. So here EBS volumes automatically replicates within its availability zone to protect from component failure. Let's say in this server it is failing, from the next availability zone, you can get high availability and durability. So this offers consistent and low latency performance on your workloads. So you can see this diagram. So you have HDD based. Okay, so throughput optimized and cold storage. And if you could see, SSD is general purpose and provisioned IOPS. So provisioned IOPS is you can have 15,000 IOPS. If you want to transfer data from your, what is that, from your drive to on on-premise, so you need more IOPS, input output per second. So you can attach this to your VM and you can run your application. So if it is a lot of requests is hitting your what is that hitting your web server and your hard disk is not performing, you can convert that to an SSD based hard drive. So features you could see. So volumes are placed in specific availability zone. Okay, they'll be automatically replicated to protect you from failure on single component. Okay, so volume types you have general purpose SSD, provision SSD, and magnetic. Three volume types, and if you could see based on the selection, your cost will also vary. And this type of EBS volumes also they provide snapshot capabilities. Okay, snapshot in the sense point in time snapshot. You can just take a snapshot and you can use it when the actual machine is going down or the volume has gone down due to some data corruption. So it is designed for 99.999 availability. So use cases you can see. You can build your own SAN, okay, storage area network in the cloud for some IO intense applications. Okay, you want to migrate mid-range on-premise storage area network workloads to cloud. Okay, you can attach high performance and high availability block storage for your mission critical application. So this can run relational or NoSQL databases. Okay, you can just deploy and scale your choice of databases, including your databases based on SAP HANA, Oracle, or whatever flavor it is. And you can also use it for your big data analytics. Okay, you can easily resize the clusters for big data analytic engines such as Hadoop and Spark. So this in this Hadoop you will see post midterm. Next is your import and export. This is for internet transfer and data transfer speed, right, from your device to portable devices. Even cloud provides the data transfer through portable devices. Okay, so see import and export supports data transfer in and out of S3 buckets, and it also supports EBS, and also it supports transferring data from your EBS to Glacier. Okay. So common uses you could see data cloud migration, content distribution, direct data interchange, offsite backup. If you want to have offsite backup, you can have full or incremental backup your data to S3 or a Glacier. Next is disaster recovery. So if you want to quickly you want to retrieve data, so which is stored in Amazon S3 or Glacier, you can use import export and you can transfer the data to the portable storage and it can deliver to your site. So you need to prepare a portable storage device using import and export. You can create a job, okay, a request in AWS. Okay, they'll get the job identifier and the digital signature. And once what they will do, they will have interface. Once it is authenticated, they will connect your device and they will supply it to AWS. They will return the device to you. So now you can see the difference, the use of AWS import and export in what speed, okay, of internet connection it provides you, like the communication T1, T3, you can see 10 Mbps, it is 100 Mbps and 1000 Mbps for T3. So theoretical minimum number of days to transfer 1 TB at 80% of network utilization. You can see the days over here. Those are theoretical values. Okay, I stop here. We will continue this in the next session. You can take up the quiz.
That's